project going to look like?
I mean, we usually have like a couple scenes of character animation that we've done.
If I animate my own character, would that be fine?
Yeah, we'll make our own characters later.
Like, because you remember that creature I was working on?
Yeah.
I'm trying to finish it as fast as possible now because I couldn't do it for holiday. Because I really, really want to animate it.
Okay. What is going on here?
I did my assignment as early as possible, so I didn't really get all the detail that you did on that we talked about on Monday, and I just didn't go back and do it.
That's for next week.
Yeah. So yeah, Monday is always the following Tuesday. Yeah.
Mind if I quickly show you something?
Hold on one second. I gotta.
Once you're done.
Yeah.
Sure, how to literally take this. For example, you talk about heading towards Earth, which made me wonder if this was about pre-Earth or possibly sci-fi. It's interesting. These questions in a poetic way today. They feel otherworldly. I see bits of this throughout the exercise.
Okay. Mario has been invited. What are we doing here? This. Okay, you guys can hear me on the live stream, right? Give me a thumbs up, please. Diana's on there. Trenton's on there. Alec is on there. I think I've pulled down everyone's videos. First things first, the one thing I forgot to cover, I think, on the OBS video was about how we can all, and by we, I mean me, avoid this. So here, yeah, by default, if you don't do anything, OBS is going to give you automatically name your recording according to a date timestamp. And so two things to be aware of here real quickly. This is under, I think, settings, I think, and then advanced, and then here. And so this is what you should know and write down, is that this is called a token. Anytime we have these kind of variables in the file name that represent something that gets included in the file name, this is incredibly useful. And it's not just OBS who does this. You can use this in almost most programs so that you can generate procedural file names, which is great because the format here is year, month, date, hour, minute, second. What I want you to do is just put your name here in front of it so that when you automatically generate your file names, you got, it has your name in there. And so then when I download them all, it's not just a bunch of dates, it has your name on it, which helps know what's happening here at the beginning. All right, so the thing that you should learn here is tokens. Using tokens to generate file names is, once you start generating a lot of files, that's a pro tip there in terms of being able to automatically name the files according to either the project number or in this case just the date. And having the date hard encoded into the actual file name I also find useful because when I copy files over, it seems like Windows obliterates the original date sometimes. I don't know, I haven't really. Sometimes I can't follow that. Just communicating with Fabio here. Yeah, so everyone saw Fabio's intro video on Discord. He's available now on Tuesdays and Thursdays. Everybody can hear me. Amy is on there too, as well. So that's good. And then just my general statement about this and about homework is turn in something. Okay? So even if it didn't go well and you have some sort of problem, you can ask the students who have had me before. I would consider myself a generous grader. It's more important that you keep up with the class, right? And so if you had a really substantial systemic problem this week and it really kept you from doing a bunch of work, you should record your video, presentation video, show me what you have, and say that so that we can solve that problem during our review time, which we'll do up here. The students who don't turn something in because there is some issue and then let that pile up week after week, they, hashtag real talk, most of them don't end up finishing the class because it just ends up being too much, right? Like, I mean, you can see the pace at which we're moving here, I think is, well, I would consider the class high density in that we cover a lot of stuff. And so the idea that you can sort of skip things and then come back later doesn't really work out here for the most part. So it's really important that you keep up with what we're doing. Even if you didn't quite get 100% of everything, you got 80% of most things. That's good. Show us what you have. So that's my primary, advice here for my classes. Like I said, even if you're taking it online, it's not going to function like other online checkmark of Canvas stuff classes where it's, we're doing things all together on a schedule each week. And then I think, who was it, Jose or Anthony was saying, like, you didn't have the Monday stuff in Tuesday's assignment? Who said that? I wasn't watching. Okay, but did you say it, Anthony? Yeah, you were saying that just now.
I thought we had to go back and do something on Monday.
No, okay, so that's at the beginning here. It'll be fuzzy, right? But the Tuesday, the stuff that's due Tuesday is the stuff from the previous week. Okay, hence that interlocking schedule graphic I made on day one. So a lot of times the things on Monday pertain to the things that we did. Let's especially here at the beginning, it'll be a continuation thereof. But yeah, so you're fine, right? Like the stuff on Monday, the stuff that we covered 2 days ago, because today, as I speak, is Wednesday, right? Today's Wednesday? Is that right?
Yes.
Okay, all right. The stuff that we covered today and 2 days ago on Monday will be the content that is due Tuesday, this coming Tuesday, okay? And so we have this overlap. Why do we have this overlap? Because this seems unnecessarily complicated. We have this overlap because I want to give everyone as much time to work on the stuff as possible. I used to have the stuff due Sunday night, but giving everybody those extra 2 days, I think helps. Okay, does that make sense?
Yeah.
Okay, great. All right. And then, this is my general advice to everybody. Okay, so if there's something that didn't work, show us that. That's really valuable information for everybody. All right. Chances are, if you're having a problem with X, Y, or Z, then everyone's having a problem with it, right? In AVC 200, we had this sort of systemic problem that kept everyone from doing it, and we discovered that together as a group. Okay. And put your name on the files. Okay. There we go. And here we go. Everybody ready? And boom. And here's Gage.
Hello, my name is Gage. Here are my 3 balls here with the tweening animation.
Good. That looks right. All right. So today's going to be anticlimactic in that, we just had 1 day, right? So we did what we could.
Computer tweening?
Yes.
I remember on Tuesday you pulled up the easing, kind of like how it is on Acronym.
Uh-huh.
I was wondering like how do you do that? Like, because I was trying to do it and it wasn't even working. It just went like whole hate in my head.
The views are yeah, down here. So dope sheet is what Gage was looking at right there. And I believe what you're talking about is the graph editor right down there, right? And so in, yeah, it's also called the graph editor in After Effects. So like,
I usually call it like the After Effects grid because it reminds me so much of After Effects.
okay, yeah, you can call things whatever you want, but in this case, I think it's helpful to use like the After Effects and Blender name for it so that other people know what you're talking about, right? So just in the sake, so we can all try and communicate with each other. Okay, here's Gage.
Your animation is done by setting 2 keyframes for an object, and that tweening is what the animation is in between. That interpretation of movement that happens in between 2 keyframes.
Yep. Okay. So that's a common confusion, right? Not interpretation. Did I spell it right? Probably not. No. We want interpolation. Not that one. Okay. Interpolation is the word. I mean, everything is an interpretation.
Hello?
Yeah, you're just now like we're just confusing everybody even more. All right, great. Nice work, Gage. Alec.
Now these are my 3 spheres. This one is moving with an easing interpolation. This one has linear, and then the last one has constant interpolation. Let me show you the tool so you can see. Blue one has easing, yellow linear, and then the red one constant. So tuning in computer animation works by setting 2 keyframes, and then the computer creates all the in-between frames that occur between those keyframes.
Excellent. Exactly correct. Cool. And Alec added some nice materials there on those. Well done, Alec. Here's Alexis.
Hi everyone. This is my file here for this week's assignment. And the different keyframes, constant, linear, and Bezier. Just play it. So how is tweening executed in computer animation? So tweening works by using 2 keyframes, and then in between those, software is doing the work for us instead of us drawing out the frames or animating the frames individually. And that's the interpolation. And so it's basically generating, positions that are pretty seamless and kind of invisible to us. So yeah, that works really well. And I've used keyframes a lot in After Effects and Adobe Animate, so I'm really excited to see how it works here. So
Yeah, I mean, it works essentially the same, right? This is a fundamental animation. If you're making things move on screen, this is the system we use for this, right? It's all there. So, yeah, like unfortunately, the names for some of the either like in After Effects, it's ease in, ease out, whereas here it'll be listed as Bezier, even though the functionality of it is the same. Yeah, just the vocabulary ends up being slightly different, but the conceptual part of it is, virtually identical in all of them. Cool. And here is
Hello, here's
someone.
my presentation for my animation. We have the rendered animation right here.
Okay, who is this? This is Is this Mark? Yes, this is Mark. Oh, over here.
And yep, that's that. And then here is the blender, the scene. Here it is, everything moving properly. And how it's doing this is via, I have to explain, tweening. So tweening is basically, tweening is done via interpolation, which is essentially an algorithm that fills in the gaps between two spots. And
yeah, those spots are called keyframes. You want to be clear on that. You got the right idea?
Interpolation is a very generalized term. I mean, it can apply to pretty much anything. Like you can do it with video, or like TV has interpolation. But for this, it's animation. And as you can see here on the timeline, you can see here how the software basically is able to interpret between these two spots, and it uses an algorithm to decide that. So there's many different algorithms that you can choose from, or interpolations, and the interpolations basically are math equations that tell the software how to get from one point to the next. So that's how tweening is done. And in a traditional way, tweening is done via manual efforts, but through software we have now, it can be done automatically through algorithms. So that's my presentation.
Okay, good. Right, an algorithm is just a series of instructions. Okay, very good, Mark. You're on the right link there. Here's our link is.
Here's my interpolation video. Yes, let me just put it on the easing in and out. This one is the linear, and this one is the constant. Here is my interpolation.
Oh, there it is. Okay. So what's tweening?
It's interpreting, software interpreting the frames in between the initial keyframes that you place using AI, not AI, mathematical algorithm.
Yeah, algorithm. Yeah. No, now there's, because AI has become so like such a buzzword. Like now, it seems like any use of math is all of a sudden like, well, that's AI. Well, it's just math. You know, we have done zero AI here, right? We are just, this is like high school algebra in terms of like figuring out how to get between 2 points on the Cartesian graph, Cartesian plane. Okay, awesome. Here's Thomas.
Hi, Casey. So this is my animation.
He's got that really awesome Lego AT-AT back there. He had that last semester too. You guys see that? He has the Lego AT-AT, AT-AT. Yeah, it's really nice. Did you guys see the new, the Star Trek, the Next Generation Enterprise they just released, the Lego? Yeah, yeah, it looks really nice. Really, really nice.
People really hate Lego at the moment because of the smart brick stuff.
I saw that happened. Like, why should I hate smart bricks?
Because it's gonna bump up the price of all.
I mean, it's already far too expensive for me to buy. So like, you know, like it's like me getting it. Like, oh, Ferrari's got more expensive. Oh, like I guess that's bad. Like I wasn't gonna, I couldn't have gotten one anyway before. Yeah. Which one? Oh yeah, the ones with a lot of like, you know, like yeah, the like open them up with stuff inside, like, you know, like those are fine, but like the other ones, I don't know.
I'd rather get one of those big Monster Hunter figurines. Those are really cool.
I haven't seen those. You'll have to post it on Discord. Okay, here's Thomas.
Top one is Bezier, then linear, and then this one is the other one.
Yeah, the Blender uses the phrase, right? So just to keep in mind, like again, this conceptually everything is the same, but for not animating, right? The Blender phrase is constant. In Cinema 4D, it was hold. In After Effects, it's a hold keyframe. I'm trying to remember what the other one was. These are the same, just meaning like no slant, no slope. Just continue that value until you receive a new value, right?
Which one is the...
And also Trenton, according to in reaction to Mark's video, says, "Nice monkey." The monkey, what is the monkey's name? Suzanne. Suzanne is the monkey, right? Like, so this has been an ongoing thing in computer graphics that like some given software or software environment will have its own like default model that's not a that's not just a sphere or something. And so in Blender, it's been the Suzanne monkey head. In for a lot of very, very early computer graphics, it was the teapot. Yeah.
Oh yeah,
Yeah. And so this, for many, like very, very early stuff, like this was like the, when you needed something to just throw in the scene to see if stuff worked, this would be the thing that we put in there. Houdini has a pig. Does the pig have a name? Can't remember. Mr. Pig?
Or like the Pixar like from like the 80s.
Yeah. Yeah, the Houdini pig is pretty visceral, especially because a lot of the examples for that include it being smashed or blown up or melted or something.
Constant. So let's see. This is a playback. And then let's see. How is tweening executing computer animation? So tweening, you set a keyframe. So in this instance, this one, we set a keyframe at the beginning with all the spheres at 0. And then I set a keyframe at the end with all the spheres going on the x-axis to 14. So tweening is the process in between. So instead of doing a keyframe going all the way down, it connects the two frames together. So you have to do that in between each keyframe. And I don't have any questions. Thank you.
Okay, great. Here's Shyla.
Hello, my name is Shyla, and here is my 3-ball animation interpolation thing. So I'll play it right here. Okay, as you can see, this one's linear, this one's the ease in, ease out, and this one's the constant. I just keyframed the X value for the question, how is tweening executed in computer animation? It's with these keyframes here, and then the computer just generates the values in between. So if I take this one, for example, the eased one, it's going to be 0 right here, and then 30 over here, but then as you scrub it, it's going to go all the way to 30. And it just kind of does the math for you. And that's about it. Thank you.
Great. Yep, that's what computers are really good at, is doing the math for us. Exactly right, Shyla.
Hi, it's Crimson, and this is my animation for the balls. So you have the Bezier, the linear, and the constant. I could probably speed it up a bit, it's pretty slow. But there you go, constant stays, the linear starts off faster, but then it stays like the same, and the easing obviously eases into it, but towards the end, they end up matching up. And the way tweening works on computer animation is that it's creating these in-between frames. Because if I click on one ball, you can see that I only have one frame at the beginning and then the frame for it at the end. So the computer is using the information generated from these two positions and is like, okay, well, if it's only moving here and not, let's say, if I moved it up, then it would make it, oh, well, I didn't save it. If I put this up and went and pinged it there, then now the computer is like, okay, well, it needs to hit this position, and then it needs to hit back out to that position. So the computer is able to fill in the blanks and figure out the way to get it to move to that location. So yeah, there are my balls. Thank you.
Yep, super. That's really good. Well done, Crimson. Here's Amy.
So this is my animation. As you can see, I animated the 3 spheres so that they each display different interpolation modes. One with Bezier, one with linear, and then one with constant. I even label them over here to make it slightly easier. So
Good. Labeling. Excellent. And Amy used that hack of keeping the same first name so they get grouped together over there so you can see them.
in order to tween your animations, you need to set 2 keyframes so that your animations can move. Without at least 2 keyframes, nothing can happen. That's all I have, so bye.
Yep, very good, Amy. That is totally true. You need at least 2 keyframes to make something happen. All right.
Hello, I'm Diana, and this is my animation for the 3 balls thing, whatever. This one is Bezier, this one is linear, and the bottom one is constant. Okay, let me play it first. Okay, so the top one, okay, let's start with the middle one because it's linear. The linear one, it's a constant speed. It doesn't change speed the entire time. It moves at the exact same speed. So the bottom one doesn't have any speed. It just changes position. Just like back and forth. But the top one is Bezier, and let me open the editor. So it starts off faster, but then it gets slower on the top of the slope, so it reaches at the same time. But here it's going downhill, so it looks like it's going slower. Wait, okay. So when it's at the top, it's getting slower. When it's at the bottom, it looks faster. So it starts off faster and looks like it's getting slow.
Okay, the part that you're kind of missing here is it's not the directionality of the line in the fact that it's up or down. What you need to pay attention to is the amount of curvature. That's what's telling us whether we're changing. The curvature is telling us we're changing speed, and the direction of curvature tells us whether we're accelerating or decelerating there. Yeah, the steepness of the line. Who is this? This is what is it? 0534. Oh. This is Anthony. Okay, here we go.
Referring to computer graphics is when the computer creates essentially a straight line from one position to another using keyframes. Linear does not allow for variabilities in motion. However, Bezier does allow for easing, which creates more natural and pleasant animation. Constant doesn't allow the computer to do this, and that leads to more stylistic animation. These are a couple examples of Bezier easing, just of all kind. No.
Okay, great. I mean, this is Edward, not Anthony. And yeah, so Edward, again, great. This will be due Tuesday, right? You're sort of ahead of the game there, but that works. You're well on your way. Okay. And Trenton.
Hello everybody, my name is Trenton Hallard. This is my Principles of Motion video going over the 3 tweening processes of Bezier, linear, and constant. Tweening is something done by the computer. It's a kind of like an automatic way of giving a smooth animation to an object via interpolation via the computer. Bezier, or ease in and ease out, has more of an acceleration into a deacceleration. Linear is more of a middle ground where it's just a predictable slide across the screen, being a little bit more on the smoother side, and constant hold is holding that single point and then instantly pretty much to the next, which is why it is both constant and holding, because it is constantly there and then it's holding, but it's also holding that until it hits that next part. I hope that gives pretty good detail into these 3 different ways, along with tweening as a whole. Everybody, thank you for watching the video, and I look forward to the feedback.
Cool. You got it. You got it, Trenton. Very good. And Aaron.
Hey y'all, for this week's assignment, as you can see here, I have my 3 spheres, each with their respective interpolation mode. I will play the animation now. As you can see there, the balls, of course, slow down and sped up according to the interpolation set by the keyframes. And I gave the constant one a bit of extra animation using the bouncing interpolation mode to make it look like it's kind of warping there. Of course, if I click on each of them, you can see in the graph editor their respective curves, with the eased having some easing in and easing out, linear just being constant, and, well, constant snapping to the position of the final keyframe. As for how tweening is executed in computer animation, as you can see kind of by looking at the graphs, the computer automatically interpolates between whatever 2 positions or keyframes that you've set for your object based on the positions, times, and of course interpolation mode specified in said keyframes.
Cool. Absolutely, Aaron. Well done. Here's Anthony.
I think I did this correctly. I made the last keyframe a bit earlier so you can see it better. So what I understand about tweening is that the computer recognizes that you put keyframes from different movements. So instead of making you draw over and over again, it places it there based on its movement and where it should go. And there's an interpolation depends on whether it's constant, Bezier, or what was the last thing?
Do you know now? Yeah, exactly. Yeah, you got it. Constant, Bezier, and linear. Excellent. Jose?
Hello, my name is Jose, and here is my little ball animation. Bezier, linear, and put it in there.
There you go. You know that's not. I'm glad.
After recording this video, but constants. I'll play it right now. Fairly short, but
So if the constant one keyframe is at the very end, like that's one of the reasons I sort of moved those in so there'd be a little bit of time so you could see it happen there. If it happens like right on the end, like it's either happening so fast that we can't see it.
tweening is using keyframes in like digital media, like computer animation or 2D animation. Which means you don't have to draw a frame or make a new animation. Tweening in like 3D animation is like using keyframes. Like for example, you could make a keyframe. You can make a keyframe for most of these balls, and they'll move like depending on the speed. Like if like say I can move this keyframe right here, and the ball will move a lot faster. I can make the I can make the keyframe a lot farther, and it makes the ball go slower. As you can see, like, the balls move in different speed. The red one's moving a lot faster, and the yellow one is moving a little quicker, but the red ball beats them to it. So yeah, there's my project.
Okay, and I think you got the Bezier and linear backwards there. Like the top one is speeding up and slowing down, I thought. Is that right?
Farther, and it makes the ball go slower.
Yeah, but the maybe you got both of them to be. They're both just slightly different Bezier. Let's watch it one more time.
To make a keyframe, you can make a keyframe for most of these balls, and they all look like.
The top one does look like it slows down just a touch at the end. But it could be the playback. See, that was weird. Oh, you're moving around there. Okay, maybe just because you moved the keyframes a touch there. It's good. Okay, and who is this? Desmond, thank you.
Week 1 assignment.
Desmond has a really nice.
This class, and I play it.
I have no idea. Is it like a steak?
Today
Is it a character?
And then the mirror one. And then the consistent was the consistent one. Okay. And then that's how I did them. And pretty much I had no question this week. The assignment was pretty easy this week, so yeah. See you guys next week.
Yep. Okay. Yep. You got it, Desmond. We all want to know exactly what your mouse thing is. It's like a. Is that one of those? Does anyone recognize the character from?
It's like a chibi fairy girl from some sort of anime or something.
Yeah. I mean, I suspect it would be an anime, but you know, I don't know.
I used to have a mouse.
Hello, I'm Lawson. This is my simple sphere animation interpolation example.
Very nice. Did you do that with the OBS puppet, or did you put that in post?
It's a third-party software. It's Vito 2. You just add it in. You can get rid of the background on it.
Okay. And so is that?
It's just different PNGs it swaps between when you're talking.
Sure.
Yeah.
Yeah.
Is it the same software VTubers use?
Not VTubers, but there's like a PNG tuber kind of thing that they use similar things, but it's
Okay.
I tried to do that last semester and it just didn't really work out.
But it's pretty
So is it an OBS plugin or like your?
No, it's just you just download it and then you can just add another source.
Uh-huh.
And you can just choose the software.
Uh-huh.
And then you just go into the settings of it and turn off or you can allow transparency.
Oh, okay. I see. Okay, so this is on your screen while you're working. You see it there while you're working, or no?
You can have it off to the side.
Oh, okay.
But I can look at it and see that it's actually talking.
Okay. Cool.
But
I'll let it play out.
Did I hit the button? I don't think I. Let me just again.
Wrong one.
That's it. That's Desmond.
Hello, I'm Lawson. This is my simple sphere animation interpolation example. I'll let it play out. Tweening works in digital animation, at least in Blender. Keyframes, you only need at least 2 of them. You need at least 2 of them, and then the computer does the math for you but there's different modes of interpolation within Blender. You have Bezier, which you can edit, but the default is ease in, ease out, and that just slows it down before it starts. It speeds it up, and then it slows it down again. We have linear, which just goes the same speed the entire time. And then we have constant, which just appears. So there's no...
Yeah, great. Did you edit those in later, or?
No in-betweens, no tweening. It just skips between different poses. One last thing to note is that keyframes are not interlinked with every single detail. You can choose to just have it move along one axis, and then you are able to move it along, say, the y-axis, and it can still follow its path, as well as the z-axis, and then it can still follow its path.
Awesome. Yep. Great. Very cool. And for everybody who wondered, what is the name of the software again?
Vedo2, so VEADOTUBE.
Vedo2.
Where do you get it? Is it from like Steam or no?
It's just online. It's free.
Okay. Awesome. I'm sure I'll see some more of that next week.
Hello, my name is Gage. Here are my...
Wait, we did Gage, right?
No, these are mine.
Yeah, and we did Alex. And Ivan, you're working on yours, right? Or wait.
Yeah.
Do we do motion video? Yeah, we did Diana. Did we do Diana? I don't remember.
Hello, I'm Diana, and this is my...
Yes, we did Diana's. Okay. And Trenton, Aaron, Anthony, Desmond, Jose, Lawson, Gage, Alec, Alexis, Mark, Linka. And everybody's coming along here. Okay, good. Okay, and if we look at this over here, and if we look at this here, cool. All right, so we'll do that every Wednesday. All right, so that's my point, trying to show us exactly. Obviously, it wasn't like the world's most exciting exercise this week because we barely had time to do anything for one day last week. As we go on, everybody's projects will start to differ throughout the semester, and so it becomes a lot more of an interesting exercise to see exactly what everyone's working on and give everybody some feedback there. So we tried to move quickly this week, but yeah, well done. Everyone got the right idea. And yeah, a lot of times, there's no quizzes in this class. The quiz is in the version of, is that, like I'll say, make this video and also answer this question. And, it's not so much a quiz as that I'm grading you. It's just a quiz to be like, are they hearing what I'm saying? Are you understanding what we're doing here? So everyone does at this point, and so that's great. Good. Okay, let's look at a slightly different version of this just to be clear here. And to let's contextualize this as we will prepare for the computer apocalypse. What if we had to do this without computers? We'll do it with computers, but kind of the paper version. And so I am going to make a new 2D animation file. Here we go. And so this in Blender here, the 2D animation stuff in Blender is under the feature set is called Grease Pencil. So that, anyways, as you're looking for other things online, it's all under that umbrella. That's what this part of Blender is referred to. And so we can do some interpolating here in this version with a few things in mind. Okay, so we're still in Blender here, but you'll notice that it's just the 2D animation view here. If I went and made a layout view, there we go, and we 0 and went back here, you'll see that this is, I didn't open a new file. This is just the layout view of the file I was just in, okay? And so this is the regular Blender version view where we can see what's happening here, and then, you know, our usual modifiers and stuff over there. If I come back over here, it's a different background color. Notice that the outliners remains the same. Over here, we're just looking at the brush settings. And then we have the brush settings, and we have the grease pencil layer settings down here. And so let's just do 3 different versions of some interpolation here in order to understand this. And so one other thing we're going to do here at the beginning is that we are going to switch from this to this color attribute. It'll make it a little bit easier to color things right off the bat. Yeah, and so now, you know, we're going to go OG/old school, right? And so before, you know, everyone knows what you understand the value proposition of computer animation. Now we're going to take it away and draw all the pictures ourselves and not interpolate, right? A good friend of mine once referred to this, like, I think this is unnecessarily negative about hand-drawn animation, but the pain of every frame, right? We're not going to make that many frames here. So like, and we're just going to draw some circles. So it'll be pretty, you know, it's not going to be that painful, but just, I think this helps really internalize what's going on there on the graph when we do this. Cool. Okay. And so we've got a couple layers down here. And so these layers function like Photoshop layers in that they can be separately manipulated. So for instance, if I have this layer selected, that means that I have the draw tool over here, and I select one of the brushes here, and I draw some stuff. That's on this layer. If I turn this layer off, that goes away, right? If I select this layer and draw something else of a different color, there we go. That's on that layer. This is on that layer, right? Basic layer stuff like every drawing program there. Okay, so with that in mind, let's get rid of both those things. And we are going to make a new layer here with this button. And this is going to be called guides. There we go. And there we've got guides and lines. And we'll go with that for now. For right now, we're just going to draw in the guides. And I'm going to make sort of a gray color just as a placeholder. And use just a thin brush here. And in addition to, you know, drawing freehand with the brush, you can also draw some shapes just using the shape tool here. And actually, I'm going to use the line for this. If you press and hold, you can get a line tool. And again, let's make it grayish. Okay, great. And so make sure I'm on the guides layer here. And if you click, and let's make it a little bit bigger than that. There we go. And so on the shape tool, you got to press enter to get the shape in there. Let's make it a little bit thinner. And so I'll click and drag, holding down shift to go straight across, and then press enter to do that shape. And let's do 3 of them. I'll go across like this, and enter, and then this, and enter. Cool. I got 3 of them that are about the same size. Gonna come back up to this tool here. Okay, and so we'll start here an end here, and let's do some linear animation. So we want the ball to go at the same speed the whole way across this top one. And so we'll divide it in half. And we can just use this dividing in half scheme in order to make this work. And so here, 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 and here. Okay. Yeah, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice that the playhead this whole time has been here at the beginning and is drawing these into the keyframe. And so now the Blender keyframe is an entire drawing at this point. And so when we just have one, it's going to extend it across the timeline there. And so if I were to scrub this now, you see that that stays there the entire time, right? And so we wanted to do that because this is the guide that we're going to use, okay? And so here under lines, I'm going to switch this to linear, just rename it. And then, yeah, let's make this, I'm going to make mine that-ish color. There we go. And remember, I switched this to whatever the name is for this. What is this? Color attribute rather than material. And so now I'm going to make this a little bit thicker. I want to essentially set out a series of keyframes across here, essentially drawing the ball in each one. And so I'm going to, where is it? Thank you. I want to get rid of that. Okay, and we'll come back over here. There we go. And make sure I'm on lines. There we go. And there. Then we can move the playhead forward and back with the arrow keys, right? And when I start making a new one here, you'll see that the other one gets grayed out. What's the name for this? Anybody know? Onion skinning. You know why? What? Yeah. So, like the outer layer of onion is translucent, right? You can kind of see through it. And so back when we're doing this, it's not like, I was an original animator at Disney. Back when they were doing this, there are layers and layers of semi-transparent paper, right? And the semi-transparent paper looks like onion skin. And so hence the name for this, right? So when we're doing it this way, and the computer is like not doing it for us, right? Being able to see the previous drawing while you're making the next drawing is obviously very useful, right? So that you know how far away is Mickey Mouse's hand from where it was the previous frame. And so this is what that's showing us. So this will not show up when we actually play the animation. And so now I'll forward again here. And so it's a little bit confusing when you forward it to the next frame. It's, it looks like it's on that frame, but it's not. And there we go. And so now I can move the ball along this linear path here. I'm just doing this quickly. Over here, I am going to zoom in a little bit to make sure I'm not skipping any frames. Cool. And now if we look at this, we have this happening, right? So I got the ball zipping across there because we're still at our regular frame rate. The whole project is running at 24 frames per second, but let's just make sure that's the case. Yeah. If we come over here to our render settings, it is at 24 frames per second. If we come back to here, 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 yeah, we've got this. Now, we've got the guides there that we set up, but if we don't want to see those guides, we can turn that off. And now, when we hit play, we have this ball animating at a linear speed across these frames, okay? Now, it's happening really quick, right? And most of the time, if you're doing hand-drawn stuff, it wouldn't be at every frame at 24 frames per second, right? What was the name for 12 FPS? Yeah, on the twos. So on the twos would look like scaling this out. So the Blender GR, well, mostly G and S, the scale and move tools work on keyframes as well. So if I want to stretch these keyframes out, I can select them like so, and then press S and start to drag, and it is scaling these keyframes in time. It's making them last longer. Does that make sense to everybody? Right? So now it's scaling the actual scale. We're scaling them in time. And so now that slowly goes across there, right? So 17 frames. If I wanted to stretch it more, again, I could sort of zoom out here. Now, the thing about the S for the scale is that where is the anchor point in the scaling? It is the playhead. So if I were to grab this, there where it is now, and press, there we go, and press S again and scale it out. See what's happening? It's scaling out from the center there, which means that this stuff here is now into negative time, which is, what does that even mean? Like before the file starts. And so then I would need to grab it, and then if you grab it like this, you can either move it or you can press G, and then you can move it back. Or what I just try to do when I'm doing this kind of stuff is make sure that if I'm going to scale a section of keyframes, most often it's useful to move the playhead back to that beginning section of those and then scale from there. And so there, let's actually put it on the threes. And so I'll press S and scale that out. So it's almost every third, should be exactly every third frame. This one needs to go over one more. There we go. And so we have that. Let's save this. File, save as. Cool. And this is on by default, which allows me to draw into the layers. If you accidentally turned that off, you're going to want to turn that back on. This is on, allowing me to see all of the animation layers there. We're good. And so, yeah, does this setup make sense here in terms of why we drew the guides? So I'm just not like freewheeling it as I'm going across, especially when I'm trying to create this linear animation. Yeah? Okay, great. So now I'm going to also try to be efficient and flexible. So I'll create some other layers for the other ones. And so let's go ahead and create one more. And this is going to be ease in. There we go. And let's add that. There we go. And I got ease in. And let's go back to guides. And over here. And I'll dial this down. Okay, so that got those two. And I want to create something of the same length. So I got 1, 2, 3, 4, 5, 6, 7 frames to work with here. And in between the beginning frame and the end frame. And so we're going to ease in to this one, meaning we're going to start slower and then speed up, right? And so if we're going to do that, remember these tick marks here indicate where the ball should be at that point in time, assuming all of the frames are equally distant temporally in time. So we want to keep them close together and then spread them out, right? The tick marks are spread out. That means the ball is moving faster. And so here, what I'm going to try and do is, rather than putting the first mark directly in half, I'm going to sort of cheat this way a little bit and continue to do that to try and get the frames closer together here and further apart over there. And again, it's just the guide. So let's move it over about 2/5 of the way, right? And so they were there. And then we're going to have to, so that's the halfway mark. I'm moving this over here this way. And so we have 3. Actually, I'm going to cheat a little bit more. Let's say over here. And so we got 3, and I need these to be closer and spread out. So here, here, here. And then I've got 3 here, 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 here. And let's move them a little bit more. Okay, so I've got a good guide now for what I want on this one. Again, made sure I was on the guides when I was drawing that so that it would persist for the entire time. And now let's go to ease in and pick a different color of some kind. There we go. And dial this up a little bit. Make sure I'm on the ease in layer. And we're right about there. And now, let's make this a little bit better. So if you have a Wacom tablet or any kind of tablet, this would be the assignment to break that out for. And so now, forward 1 frame, and let's move the ball just a bit there. Forward a frame, a little bit more. Forward a frame, there we go. Forward a frame, right in there, right in there, right? So I'm using it as a guide, right in there, right in here, and then right here. And again, let's spread these out so they're about this, right? Because now this one's gonna, ease in, but also run way, very, 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 very quickly. So let's spread this one out, come back here, press S to right about there. And pretty good. I'm going to go ahead and change some of these. Let's say here to there. I want that one closer. So let's take care of this one. And then here, I'm going to move this one a little bit further too. And so without the guide there, and move that one a little bit closer. Cool. Okay. So this one's taking longer because it's slow at the beginning and then it's picking up speed and getting there. We're doing it over 7, 9, I guess, total frames. So we're covering a lot of distance over there, but it's fun. If you want to make more frames, feel free. Then let's do one more here. Right, so if this is our, let's come back to here. Here. Right, if this was our ease, if this was our ease in, right, our ease out, meaning that we start quickly and then we slow down at the end, is going to look like what? Where are the tick marks going to be more dense? If we want to be slow at the end. At the end, yeah, because that means the drawings are getting closer together, right? Given the same amount of speed. So before, when we were manipulating what's happening down here in order to make the change in the speed, now this looks identical down here. It's just we're moving how much ground we actually cover in between each part.
So basically it's the same system as like Adobe Animator, almost?
Yeah, this is just, it's a basic system as in basics. Like this is just a series of pictures at a consistent frame rate.
No, yeah, I know. Because
Yeah.
I worked on that.
Yeah.
On my own time, so.
Yeah. Yeah, I mean, I would encourage you to separate your knowledge base into conceptual fundamentals, things that are true regardless of software, and then separate from that, and far less important, is like how this software implemented it or how that software implemented it. Right now we're at like a really, really basic level. We're just talking about individual pictures shown at a specific time. Yeah. So Adobe Animate, any animation program that does frame by frame animation is this same concept. We have a series of pictures happening at a fixed frame rate, and then we have onion skinning in a way to tell what happens, in the previous frame and in the next frame, right? Okay. So as for all of the other examples, right, and as we go on, I'm going to leave the last one blank more often, right? So again, this is going to end up being kind of like a quiz in the homework where like if this one's going to be ease in, this one is going to be ease out, right? And without me doing it as an example, can you get there? And so I'll also go in and add some labels. I've got this extra layer here, so I guess I'll use this. Doing this with the mouse, so it doesn't look that great. And then down here, our last one, right? So if you get back to 0, that puts you where you need to do. When I move the camera, if I just press the middle wheel and start moving around like this, it goes into 3D orbiting. 0 snaps it back. If I hold down Shift, when I move the middle and the scroll wheel, it keeps it in that 2D movement. And then the scroll wheel sort of zooms in and zooms out. So if you get out of that there and you see like what's going on, right? So this, what we're seeing here is part of what I think is really nice about Grease Pencil is that it's like in the 3D environment, right? And so if we wanted to here, we can add, three-dimensional things to it's all just points, edges, and faces for Blender. And so that's super useful. We'll use that more coming up there. So if we were to if things get really messed up here, you can come back and say 2D animation again and get yourself another layout. And then, yeah, our next one here, we brought this in, make sure that we are in draw mode. Why is it not giving me draw mode up there? There we go. You have to make sure you have the grease pencil selected, and then we'll get draw mode. And we're back. And then down here we'll have ease. Make sure I'm on labels. There we go. How many of you have some sort of drawing input tablet? Great. And then for those of you online, everybody can still hear me there, right? I'm going to turn the camera around for a second. Let's see, does that work? Yeah, there you go. And so now you can see, for those of you who have not been back here in 134, Ivan, where's your hand? There he is back there. We have two, what I'll call super setups with Wacom tablets already set up there with the computer, right? So these are really nice 26-inch Wacom tablets that are there for you to use, and they would be super useful. Even if you just came in and just did this scene here, that would be definitely useful, right? So we'll do linear, ease in, and ease out. But going through the process here and laying everything out, I think is super useful in terms of like understanding exactly how this would work, even in that context, to really fundamentally understand what's happening. Everybody with me there? Okay, so that's your other scene to put together here, linear, ease in, and ease out. Another thing to keep in mind, the scaling of the keyframes, which is super, super useful. Let's go ahead and save that. And cool, let's come back and look at our reference. Okay, great. I think we've thoroughly explored what's going on here with these now between all those examples plus doing the hand-drawn stuff and the things we did on Monday. Yes? In terms of understanding fundamentally frame rate and everything else. So the hand-drawn one ultimately ended up being on the 3s. Okay, mass and weight here. So when we're looking at this one, if I were to blow this up some more, let's see if I roll up here. So looking at number 3 here, how is it being, this is a really good example in that we have visually identical objects. How is it communicated whether they're light or heavy? Number 3.
How much it bounces on the surface.
Yeah, how much we're bouncing, right? And so a lighter object is going to bounce higher, right, than another object. So in this one, I like to think about our mass examples. So whichever way you want to think about it. Think about a bowling ball that's the size of a ping pong ball, or perhaps more fun, a ping pong ball that's the size of a bowling ball, right? And they're both the same color. If we dropped both of those, right, kind of visually indistinguishable, how would we tell they're different in the bounce? Like, how is the bounce going to look different? And so when it bounces more, the ball's lighter, so it bounces up further, right? So the distance it's covering is further. And then also that means it's going to bounce longer, right? Through a more amount of time, right? You drop a ping pong ball and it seems to bounce for like a good 2 minutes until someone manages to crawl underneath the table and like get it out from underneath wherever it's going to be. If you drop a bowling ball, it's a big bang, but then it's kind of over within seconds, fractions of a second probably, right? Because it stays closer to the ground there. And so I really like this as an exercise. Can you animate weight, right? We're not going to do any 3D modeling stuff. We're not going to make one look like a ping pong ball and one look like a bowling ball. You have to communicate the weight just through the movement of the object. Make sense? Okay, let's set out to do just that. And then we'll apply it in a little bit different way. And so I'm going to do this, save as, and this is going to be weight. And I'm going to turn these labels off for right now, and then delete these. Okay, good. So now I'm going to take my camera, and I'm actually going to Alt-G the camera to make sure it's in the middle. Move it directly back, just makes it easy to see. There we go. Okay, and let's get our sphere here and drop it and make it light. Okay, and again, I'm just going to make it, we're going to worry about the up and down for right now, right? And so with this in mind, I'm going to make sure I keyframe just the Y. Let's make it a little bit easier to take care of all the other stuff later on. Or if I want to copy and move this somewhere else, I can take care of it. Or sorry, not the Y. Up and down in Blender is which one? Z. Yeah, sorry. Boom. Okay, so let's move this over here and do this. Let's make it a fun color. And let's get over here. And so the first thing, block out the animation. We need to start here, down, up, down, up, down, up. And we want a decreasing amount of time for each one. So here, and let's go ahead and move it forward to here. I'm going to move it down. That's where we're impact. And we'll keyframe there. And now we got to go back up. But we don't want to go up as far as we did before, maybe a little less than half, or right, a little more than halfway. I like that. There we go. And now I want to make sure I hit the ground again. And so in this case, I think it makes more sense to copy and paste the ground to there, right? So that you're not having to get that wrong. Well, now this is, remember this amount of time here, this is a complete bounce, and now let's have a slightly shorter one. And so I might think about this length here, make it a little bit shorter, and then in the middle, this has got to come up here. Make sure we got one of those. If you want to adjust it here, you can. And then let's keep going a little bit shorter. Keyframe, again, copy paste, move this over, whoops, just that one, and one more. Keyframe, and paste, and maybe one more. keyframe, and paste. Okay, the bounces get shorter. That's good, right? But they don't look like bounces yet. Why not? Not Arlinka. Why does it not look like it's bouncing? Very good. What can you be more specific? Yes. Okay. Right. Here we're easing in. Assume the ball was suspended in air, right? And what does gravity do on the way down? Speeds up, right? And then the problem is here, Anthony, what is happening right there? Slowing down as it approaches the ground, right? Which is not what gravity does. Gravity speeds up the entire way. And so our keyframes here on the ground, we can grab the handle, but the problem is the handles are balanced, and you need to say handle type free, so that then you're able to do this with the handles and make them this fashion. And so I think I'm going to grab all three of these handles. Can I get them all at the same time? Shift, 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 right click, free. There we go. And so now I can tune the handles there so that we are accelerating into the ground. Whoops. And same thing here. And same thing here. And conveniently, this ends up looking like a bounce here. The other thing we can do is spread out these Bezier handles on the top in order to sort of hang in the air a little bit more. Right here. There we go. Once you have two of them, then if we want to do more bounces here at the very end, sort of that ping pong ball thing that happens when it gets really, really close to the ground, we can grab these two, Control C, and then the last two there, you can create another bounce pretty easily by doing that. The key is here at the end, sort of decreasing the amount of time without getting the bounces super, super lopsided. Let's see how that looks. Again, Control Spacebar, and let's see here. Let's save this. What do you think? And looks like, you know, some sort of light-ish, maybe not quite ping pong ball, but light ball, right? And so now we want something in comparison to this that is going to be heavier, right? And we're not going to get, you know, like there's the whole issue of like, as I'm sure you've all learned in physics class, you know, like if we drop a bowling ball and a feather in a vacuum, gravity exerts the same amount of acceleration on both of them, but that actually is not, in a non-vacuum, the air resistance on the feather does actually make the feather fall slower than the bowling ball. So we're not, you know, the bowling ball here, I think could fall a little bit faster, and then also it's going to not bounce as much, right? Right. Think about dropping something really heavy. What is that like? Like you drop it, and like maybe there's that like kind of like one bounce skid, like a little bit, and then it kind of comes to rest there, right? As opposed to this one, which just kind of like is continuing to bounce there. Everybody with me? Okay, so let's use this as a starting point. Now that we got one in place, I'm going to call this sphere parentheses light. There we go. And I didn't type the name. There we go. Parentheses, light. And there we go. And then I can Shift D this over to here. And again, this works because, again, I only keyframed the Z, okay? Just like we only keyframed the, what was it, X last week or something like that? Yeah, okay, so good. Now I've got this one here. Let's rename this one heavy right off the bat. And then go from there. Okay, and in this case, I'm going to turn this thing on so I'm not getting confused in the view here as to which one I'm actually currently editing. So I want to make sure we're just doing the heavy one here. Okay, so I know we want to just have, you know, one, maybe like 1.5 bounces here. They're going to be pretty low. So I'm going to get rid of maybe this amount of stuff, delete those keyframes, and then, yeah, it's not going to bounce as far back up, right? And so this one here, what direction does this keyframe need to go? Up or down? If I wanted to bounce less on that first bounce, bounce up less. Down, yep, yeah. And so this needs to come down. You're going to need to wrangle your Bezier handles here, right? Because we don't want this kind of thing, right? That's all going to result in some weird animation. And so let's do this and then take this one. If I'm moving this, if I hold down Shift, it'll lock it in so I can't move it up and down. So it'll stay in that correct position. And then maybe just a really tight skip then after that, like so. And again, the bounce is getting shorter. Again, I'm holding down Shift, maybe there. And remember, when you start zooming in like this to really do this fine-grained work, remember, your keyframe has to be on frame 54 or frame 55. You can't go in between those two frames. That's what animation is. It's a series of pictures. You can't have something be in between the pictures. That doesn't make any sense. So this is probably even lower, like that. These Bezier handles, you don't want this to be too U-shaped. And so here, and bring these down, bring this one down. There we go. And so let's see how that looks. Okay. Still way too far up. Let's say here, I'm going to move this down quite a bit, like that. There we go. And do a bunch of wrangling, right? So when you bounce up higher, the bounce has to become shorter in time as well. And so we got to move some of these and move this even more. You want to make sure the Bezier handles don't extend way beyond the lines. It makes it much harder to make it work. There we go, about there. Gonna make this one even shorter. In general, trying to keep them symmetrical. If you have an odd number of frames, it's going to be, well, impossible. or an even number rather. And we want it to go up even less here. The second one, it's really just kind of like a skip. That's pretty good. And here I said we'll do bowling ball rules. So maybe it does fall faster. So this one, if we move this over a few, that's going to help communicate that. There we go. Now that one feels like it's thunking versus the other one that's bouncing. So visually identical, but trying to communicate the weight only through the motion. If we look at them both at the same time, turn that off, there they are, right? So the light bounce and the heavy bounce here versus here, heavy, heavy, light, heavy, light, right? Heavy one, just this barely little skip here at the very end. Especially if you can pull this off in just the keyframes, that's going to be super important. Once you start to add visual distinction to it, then you can really communicate something that has weight to it at that point. Okay, let's try this with not position, right? So it's one thing to apply this here, but what if it was not a ball that's exactly like our example? What if it were, here, let's brainstorm. What other kind of like simple machine kind of things could we make that are light and heavy? What about a rotating hammer? Yeah, maybe it doesn't go back and forth like this, but maybe it's a hammer that's sort of like dropping onto something, right? So like a lighter one or a heavy one. Make sense, right? And so what if it's a hammer that's rotating down like this, right? What parameter are we going to need to actually animate? Right, but is it going to be position, rotation, or scale? Rotation, right? Markedly different from the other ones that we've done. Okay, so let's make a hammer first. We've got this. We're going to need a couple things. I'm going to Shift A and give myself a cylinder. I'm going to make sure that cylinder only has like 16 radial vertices over back this way. Let's make this thinner and a little bit longer. There we go. And then we'll get another cylinder, or even longer. How about, yeah, like that. Okay. And a little bit thinner. Okay, that's good. And then I'll Shift A and make another cylinder. This one, we'll make it thick and short, kind of like that. Okay. Cool. I've got these two things. Let's take this cylinder here, and I'll move this up and rotate it over. Hold down Control. Make sure it goes exactly 90 degrees here, like so. And we got ourselves a hammer. Let's right-click and shade smooth. Oh, no, let's... we'll shade auto smooth on both of these. There we go. Now I've got those two cylinders. I want this to be one thing so that I can just animate it as a whole rather than managing both cylinders. And so what's the shortcut for joining these in Blender? Good. Control J. Right? And so it's like this, and Control J. There we go. And I'm going to rename this to hammer. Okay. And I will look at it, and I were to rotate it. Okay, that's all right. But Anthony, what do I want to change on this hammer? If I wanted to do this. What is this here, Jose?
The cursor.
Yeah, the cursor, the anchor point for this, right? We want to move the anchor point. Remember in Blender, Arlinko, what's the Blender word for anchor point? Origin. It's in the Blender documentation, they'll refer to anchor points as the origin, right? And the ultimate origin is the cursor, which isn't necessarily at the actual origin. You can move it around. But I don't use the actual cursor thing very much. Cool. And so here, go to 1, so I can see it from the side there. And in this view, I'm going to press N, and then Tools, Origins, and then let's move this down to here, right? So the object isn't moving, the anchor point is moving. So I'm moving it down, and then I'm saying, now I want to go back to manipulating the object, and so now it rotates from there, which is what we want for our animation, right? So in every instance, before you animate, fix your anchor point and origin in Blender. This is a universal rule. Changing the anchor point after you start keyframing things is just, I mean, a formula for disaster, right? Either you start over, or you have to add additional animation to compensate for the anchor point moving at some point, right? Ends up being not great. So you want to get that fixed beforehand. Cool. Okay, so we got that in place. Awesome. Let's give this hammer a fun material. There we go. Yeah, we're going to do heavy and light hammer. So again, let's go back to just the hammer there. Got it just this way and zoom in a bit. And so here, this is going to be like, like that when you test your strength at old-timey carnivals, and you have to take a sledgehammer and smash it on the thing, and it goes the whole way to the top, and it tells you how strong you are, or in my case, like, wow, you're a weakling. Then this will be one of those. But we have two hammers. Again, just like the other exercise, two hammers are visually indistinguishable. One of them will be heavy, and the other one will be light. And we have to communicate that just through the keyframes, which are going to be rotational at this point, right? And so here, let's come in and figure out which keyframe we need to set. It's going to not be X rotation. In my case, it's going to be Y rotation. If you set up your scene a little bit differently, it may be a different one. But again, we're going to be conservative and just animate that one parameter. And so there. Actually, let's go right about there, so it's straight up and down. There we go. And same thing. Let's block out the animation here. And so we need that first keyframe to be right about there. Again, setting that keyframe, coming over here. If you click, this is a word that comes up again. Anybody know what this means? Yes.
So that the graph can fit completely on your screen.
Yeah, so when I press that button, then we could see what's happening because this was like way down there, right? So the word normalize, you have some kind of data that's on a graph, and then you can rescale it. So it has the same difference, but just within usually a 0 to 1 range. That's what the word normalizing means. Okay, great. So we have that. And now let's bounce back up. And so that's got to come back up. And doesn't go as far, but kind of maybe here, right? And then back down. And I'll do the same thing I did. I want it to impact the same thing, Control-C, Control-V, right? And then same thing here, making sure it's a little bit less time. But and a little bit less distance, right? So this is the light hammer. In this case, like literally, right? It's like a glowing light hammer plus a physically lightweight hammer. And then, Ivan, what's the problem here? Or is there a problem with this hammer? Does it look like it's dropping?
No, it doesn't look like it.
Okay, and why not?
Because it's like it doesn't feel natural.
You are correct. I'm going to ask you to be more specific. What is wrong here? What does this curvature before we hit this keyframe mean? What does this curvature mean for the speed of the hammer rotation?
It slows down the hammer.
Right. It's slowing down the hammer at the end when it's getting very close to the ground, right? And gravity is going to demand that it what?
It demands it to like
fall faster. That's what gravity. That's the problem. That's the fatal problem with gravity, is that it keeps speeding us up until we hit the ground, right? Which is fine for like 5 feet. It's bad news for like 50 feet, right? Right. Yeah. I love doing this. Right? It accelerates the whole way towards the ground. At some point, I'm going to break that remote, and then I'll have to get a new one for the TV. But it'll be, it'll be worth it. You think I'm going to explain that to them?
I had to urge to interrupt him.
Yeah, I should get we should have a ball here that I can throw, right? Yeah.
You just get a toy ball at Walmart.
Yeah, I want something more interesting. I want a bowling ball sized tennis ball, right? Like they have on, you guys watching the Australian Open, they have those giant basketball sized tennis balls that players sign.
You can find it in like big sports.
Yeah.
I actually had one of those.
Yeah? So I'm doing the same thing here that we talked about before. I did the braking, what is this? Right click, handle free, so that I can move the handles so that we can accelerate towards the ground. Here, let's look at this again. Boom, boom, boom. Okay, so that's giving us something. It does feel a little sluggish to me, slow. One other thing here is that I can increase the amount of hang time by dragging out the handles here at the top to go from more of a triangle to a U shape. That's going to help a little bit. That's going to make it seem like the thing it's hitting is bouncier. But again, I'm not keyframing position, I'm keyframing rotation here, right? That's the new thing that we're applying to this.
I don't know if you catch my my text on Monday, but I said something about motion blur, I like the effect on it.
Yeah. Okay. When we're done with this one here, we'll investigate that topic for a second. That's true. Motion blur is going to help communicate speed, right? But we have some more work to do here in the keyframing besides that. Yes.
Would it also not be better if it aims down? Because now
Yeah, well, I think it's too slow to begin with, so we're going to have to like smush it, and that's going to give us more time. So I think we'll be able to have it, go down again. Yeah, I think what helps to communicate the light ones is, we never really see the end of their cycle here, right? Like, I mean, we're only going to do a couple seconds of this, right? So if they just keep going, it's very much like that tennis ball, infinite, or ping pong ball, sort of like infinite bouncing. It's just still bouncing, over there. So it just keeps going. But we need to smush these in. And so if we grab these, we can do it here too. If I come in and line that up and then press S, you can, actually no, that's going to scale in all directions. I could say SX. Nope, doesn't that work? SZ. There we go. Yeah, it is SX, right? So if I just press S, I just pressed S before when I was in dope sheet view, and that was fine to smush the timing. Here, I want to smush in graph view this way. And so S and then X is going to scale in this direction. And then I can also slide these over, holding down Shift. Be a little bit more like that. And so how does that feel? That's better. Feels bouncier, and that gives us a little bit more time. Again, we can come in here and do this sort of thing. So Control C, Control V, maybe move this in. And so, yeah, I know, right? So just like Jacob used, and did someone else use it? I can't quite remember. I know that this is here. Okay, the bounce interpolation thing here, I am hereby banning it on this assignment, right? You need to show me that you can keyframe the bounce, because that's just one bounce, or it's just like one, like we're becoming bounce experts here, like in terms of understanding how to control the bounce. And so here we go, Control C and Control V and Control V, and now these can come down each time and also get shorter each time. And maybe one more. Control C, Control V, there we go, like this. There we go, and maybe they need to decrease more, decrease more, decrease more, there we go. But you don't want them to get all distorted and lumpy like this. Gravity is not lumpy. Right, it's not going to do this sort of random acceleration and deceleration. It's very uniform in the way it's applied. So you have to come in and wrangle some of your there we go, and there we go, there we go. Let's see how that looks. There we go. Right? So it's a light hammer that's hitting a very bouncy thing. So the same concept, but applied to rotation rather than position that we had before. Right? This forces you to really, really become very familiar with what's going on with the curvature in the keyframes. Everybody still with me there on the live stream? Give me a thumbs up. Okay, great. Let's do the heavy hammer. And so we got this one. Let's name this one hammer. Hammer, don't hurt them. How many of you guys know who MC Hammer is? Jose? Just Jose?
I know more than I like to.
Mark, you know who MC Hammer is?
Like that song, it's Hammer Time.
Yeah, it's Hammer Time. Yep.
The only song I know about him is Can't Touch This.
Yep, Can't Touch This, MC Hammer. Stop. Hammer Time.
Fantastic Four did a thing where things or
Mr. Fantastic?
No.
The Thing? Oh, Ben Grimm.
Ben Grimm. It's come up with time.
Oh. Yeah. Well, I mean, it that catchphrase is much older than it's Hammer Time. That's older than me.
Oh, it is?
Yeah. Fantastic Four is one of the like very early Marvel characters. So that's like 58, 62, somewhere in that range. I'd have to look it up, but they're in that initial group. Yeah. Trenton, this stuff and the stuff we did on Monday is going to be due on Tuesday. Oh my gosh, I can't believe this. It drives me insane that you click on this and you don't get the calendar anymore. Like what? What are they even doing? Here. So what is today? Today is it's going to be due on the, no, not the 3rd. Is it next Tuesday already, February 3rd? Yeah, February 3rd. Okay, it'll be due Tuesday the 3rd. Yeah, both parts. Yeah, we only had one day last week. So this week's assignment will be, yeah, so FYI, last week, getting to know each other, easy start, one day class. This will be a larger assignment, right, for this time. So more typical. Okay, cool. And so based on, we got Hammer Heavy here, and let's look at this, and look at what we got, and look at this. Right, so this, I just duplicated the light hammer to start with the Hammer Heavy, right? What would be your advice to someone else to turn this into something that looks like heavy hammer falling over? We're going to need less what? Less bounces, for sure, right? And so let's get rid of these. I'm going to go ahead and delete those. Okay. And then, Lawson, what has to happen on this first bounce to change it to look more heavy?
It has to go faster.
So
it needs to be lower.
Lower, right? It's not going to bounce up as much, right? Because it's heavy. And remember, faster means that the bounce will take less time. If we go up less distance, this distance needs to also decrease, right? And so let's bring this down like this. Again, make sure it's not lumpy. And so that's going to require some Bezier wrangling. And maybe bring it in. Remember, when you're moving the bottom frame, holding down Shift will sort of keep it from actually changing, especially if you had it impacting with something that you could see, which we don't in this case. And then, yeah, it's probably easier to delete these and then just copy and paste these. Control-C, Control-V to use that as a starting point for the last sort of chip bounce here. Yeah, I once dropped a very heavy air conditioner out of a second-story window, and it was, it barely bounced. So my gravity experience is pretty.
And why did you do that?
We didn't do it on purpose, that's for sure. It was a horrible accident.
Someone told us a story the other day that a person once died because a watermelon fell out of the plane and the person was in the exact spot the watermelon landed.
Yeah, I mean, this probably happened. It seems like the definition of sort of freak accident there. That's awful. Okay, and so take notice how quick this last chip bounce is. This is like 3 frames, very, very quick, right? And how many? We're going 24 frames per second, so it's just like very, very, very short there. Cool. Let's see how that works here. Okay, the first bounce is too much. They both need to be kind of chip bounces. So again, grabbing these here, moving the playhead, SX, sort of move them in a little bit more, grab these and move them over like so. Wrangle some of your Beziers. Having flashbacks to that whole air conditioner episode. It was traumatic. There we go. All right, so if you look at that now. And now the thing that we did with the other one is that, you know, we did the heavier thing will sort of fall faster, and we will acknowledge that that's not true in the vacuum, but will certainly help us communicate its weight. And so I'm going to move these over this way so that we fall and hit the ground a little bit faster. Maybe this one doesn't get quite as, there we go. Nice. So again, visually identical, but one is much heavier than the other. You guys getting the idea, right? And so taking it the next step, we took the fundamental principle here of weight, and we got it happening this one. So what are you going to have to do this week? You're going to need to do a few things. One, we're going to do the frame rate composition here, where we talked about that. Let me go ahead and save this one. The frame rate composition, the tweening curves, the hand-drawn tweening, where we actually change the interpolation, or rather the frame rate, or viewable frame rate on all of these things. There we go. Remember, this worked because the whole composition is at 24 FPS. We were able to contain these within that number, right? Because it can be divided by those. And then your advanced project here, the one that I'm not going to cover, is that I want you to make a hammer very much like the one we made, to one that's going to hit a light ball and one that's going to hit a heavy ball. So how would the light ball animate and how would the heavy ball animate? And the rules are going to be the same here. The two balls need to be visually identical in those two instances. Just sort of throwing that out there, knowing what you know now, does that seem doable? Yeah? Yeah. Did you put in for a computer from the school?
No, this is my work, or like my family computer. It's basically, we don't have like a desktop.
Uh-huh.
So this is like,
Right, but we have the free computers you can borrow from school.
No, yeah, I know.
Okay, well, if you want, it might be a good idea, right? Because, yeah, fill out that form. It's free for the whole semester. Did anyone else get one? You got one? That one that's one right there? Yeah. So we have those computers to hand out. I think there's still some left. I'm not totally sure.
I'm doing it right now.
Okay, great, super. Yeah, that's a good call. Okay, awesome. So, really breaking down these fundamentals here, both hand-drawn and computer keyframed, and then can you apply them when two objects interact with each other, right? Hammer hitting light ball, meaning not lightweight, and hammer hitting heavy ball, heavyweight. So there's two things to think about. What would the ball, how would the ball move, and then how will the hammer react to the ball that is making contact with? So you have an action and then a reaction as well. Sound good? Yeah. Okay, awesome. Let's make sure no one has any questions. We'll be covering this on Monday. No, this last part here is not covered. This is all you. Yeah, okay, so Fabio looked it up. The first time the Fantastic Four appeared was in 1961.
Wow.
But I nailed it, right? I said between 58 and 62, didn't I?
Yeah, you did.
Yeah. Boom. Yeah, that's like the original Stan Lee-ish time, and Jack Kirby when they're doing all those characters.
I miss all the Stan Lee appearances in the movies.
Yeah, that was all great, for sure. Yeah, awesome. Okay, let me